Each time either multiple choice or marks, two marks questions, something like that. Okay. But you
Okay,
have
sir.
to a little bit more on small problems. Like it is easy, but 2 marks. If you know understand it, you will be able to do it. So, but it will not be a long questions like previous years, because here we don't have online exam is short question based mainly. Okay. Hmm. Hello.
Yes, sir.
Anybody has any more questions about anything? Then let me pull out the, if you have a question, you ask. Otherwise, I just briefly do the. I'm just looking. Jahang, you have the assignment with you. You can share. I'm just looking.
Yes, sir, I can try sharing.
Sent nahi, either sharing, screen share.
Okay, yeah.
You have laptop with you?
Yes, 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 I have.
So I'm making you the co-host, so that almost all of you have done it correct. So, but I'll see, because as you have done the assignment, it will help you in the exam, because it will be in similar direction. Okay. But you have to understand the assignment, because exam it will not be very like, not like memory from note you copy paste. There might be some problems like that, but there will be some problem where you need the basic concepts clear. Okay. Yes.
So is it visible?
Yes. So homogeneous and isotropic and non-homogeneous. You know, for example, there are many such. Suppose I give you a homogeneous electric field in a room. It is homogeneous, yes, because the value of the electric field is same in every point, right? But it is not isotropic because electric field has a direction. Clear? Something like that. But what will be the other way around? Isotropic but not homogeneous. Suppose the density which changes radially from, say, center of the earth. So it is isotropic because every direction it is same, but it is not homogeneous because if you go away, that is same for dark matter density profile in galaxy, in a sphere. As you go away from the galactic center, it falls, but it is isotropic in every direction, something like that. Okay. And this one is very easy. Almost all of you can scroll down, Jahan.
Oh,
So how the, if you know W, you know how the equation of state control the energy density, and then from there scroll down. You have to equate the two energy density. You have I have an initial condition in the beginning I told. So if you equate, most of you got it right only. So 0.7 something like that. Almost all of you got it right. Yes. Any question on that? It's very simple. It's just how rho changes with time, and omega is just divided by rho c. Now this one is even simpler. You know that from G boson and G fermion, the 7/8 factor comes because of the, why it comes? Who can tell? Why there is a difference between boson and fermions? Who can tell? Why the 7/8 factor? One is Fermi Dirac, another is boson. So when you do the integral, it is different. Okay. Okay. So these are the basic thing you should understand. That like that. Okay. So if the notes, whatever I send you, if you understand that, not just memory में ज़्यादा काम नहीं आएगा, because you have to understand it a little bit, and then you will be able to do good in the exam. And these are very simple, and you can hear my lectures. It is there already recorded. I have explained it. So now there are 5 fermions like neutrino. So all fermions have degrees of freedom 2. Then why there is a multiplication of 3 again? Oh, 3 flavor, but okay. So here I meant is 5 flavor of neutrino. Okay, because 3 neutrinos, and I have told you 5 neutrinos. So standard model we have 3 neutrinos, no? Yes.
Yes, sir. So when we get like 5 neutrinos, that doesn't mean that like each will have
No,
three
no,
flavors. So
no.
we don't.
Each standard model, when we say 3 neutrino, it doesn't mean that it is 1 neutrino giving 3 neutrino. No.
Oh, okay.
Okay. So these 3 factor will
Okay.
not
So
be.
then will be like 10.75 almost.
So some of you got it right, 10.75. I checked it today. I have not given the marks, so some of you got 10.75. Okay. Then clear this
So
one, and
here
then
the temperature, neutrino temperature and
so that I asked in the assignment. No, I have asked you to take same 11/4. No, see, neutrino temperature is equal with photon temperature at early time before electron positron annihilates, and it becomes different after electron positron annihilates, isn't it? We did that. This
yes, sir,
T
yes.
gamma was new in the beginning, so depending on what I am asking, you have to. So I think I told you to take the standard model means at present neutrino temperature, so you can take 11/4. Okay, but even if you have not taken that, that means then you have to mention that at what time you are doing it. Okay.
Okay, sir.
If you are doing it earlier than 511 keV before the electron mass, that time electron and positron has not annihilated, so entropy did not change. So that's why the T photon was T gamma. But if you do it later, after 511.5 MeV temperature, then you have to take 4 by. So whatever you take, you have to tell that whatever you are taking that. Okay.
Okay, sir.
Okay. And then anymore, the last one is very easy. You got it because what was the question that yeah.
Yeah, it was like if we are currently we have a measure of the temperature. Like if we are looking some 4 billion years back, what will be the cosmic microwave background temperature?
Yes. So that's also easy because now we are 14 billion years almost. Yeah.
Yes.
And then you are going back 4 billion years where, so you are looking back around 10 billion years back, isn't it? Yes.
So if you're looking back like 4 billion years, then we'll be looking from about 9 billion years to the Big Bang, right?
13.7 actually.
Yeah.
So 9.7.
Okay. Yeah. Okay.
So that observer for that observer, photon has traveled around 9.7 billion years.
Yes.
So then you can you can see that how much it will be redshifted. Yeah.
Yeah.
It will be just a ratio of 9.7 by 14 of the present wavelength we see.
Yeah.
Means they will see a shorter wavelength, isn't it?
Yes.
Because the photon has traveled for lesser amount of time, so it has redshifted less because universe has expanded less. So the redshift is just proportional to the time because temperature or time or temperature. I think it is redshift is proportional to temperature. No, so it is not linear with the time, isn't it? So you have to convert this time into temperature. You have to check it that how time goes with. So what was the temperature of the universe when the universe is 4 billion years back? Or you can even find out what is the redshift. You know, there is a relation between time and redshift or time and temperature. Okay. That you should find from the Google. It is there in many books as a chart. Of course, you can derive it, but you don't need to derive. It is there. So there is a relation also, a software. If you give the time, it will give you the redshift, okay, in the universe. So you have to find out the redshift. What was that redshift when universe was 4 billion years back? Anybody has done that? 940? I think it will not be 940. CMBR is around 1100 redshift. That is when universe started at when point 3. 4 billion years before today will be how much? How much? You are calculating. Oh, online calculator. Okay. Time and redshift. Oh, okay, then it's good. Yeah. So 4 billion years back. But you check. Huh? Ha. Okay. You check that also, no? Okay, then it's good. Yes. So if you know the redshift 940, and today we are redshift at how much? 0.
Yes,
Yes.
sir.
So the wavelength will be around for the alien, it will be just redshifted by the difference, of the CMB redshift 1100 divided by 940, and here we are 1100 divided by z is equal to 0. 1 plus z term is there, so basically 1 will be z will be 0. So now you know the ratio, no? It will be something like 1100 by 940 or something like that. Yeah. Hello. Oh no, 1100 and that will be. Anybody has Avinash? What is the answer you are getting? Is it clear or it is a little bit confusing? So
Bit confusing.
you know how the lambda redshift. Lambda is basically, if you are we did it, no, that example that lambda observed by lambda emitted, it is basically the ratio of the redshift of the two objects, isn't it?
Yes, sir.
Yes, sir.
So today we are at redshift 0. So ratio of the redshift nahi hai, it is 1 plus z term basically, or ratio of the scale factor. Scale factor is 1 plus z, no, 1 by 1 plus z. We did that derivation by that definite integral limit. You remember, two things are emitting lights, pulses. Yes. So now CMB emitted by CMB observed today is nothing but 1 plus z CMB divided by 1 plus z today. Yes. So that is the wavelength. Now wavelength is inversely proportional to the
Temperature.
exactly temperature. So that now you know what is the temperature, and then do the same thing for an object, for an alien who is 4 billion years back from now. There is a calculator. Avinash can also give you the formula. You can find out what is the redshift of that time. Yes. So then you can do the same thing from CMB. It was emitted 1100 and it reached the alien. So how much will be redshifted, and you do the inverse of the temperature. Inverse temperature will go of inverse of it. Is it clear now? Yes.
Yes, sir.
Just arithmetic. How much is the answer, Avinash, you got for the alien? 3.7, and we are at 3.2.7. So see, it makes sense. because he or she will watch a higher photon temperature, because it makes sense, because photon has not cooled down that much.
Yes, sir.
Very nice. So that are the simple concept. Okay, that's it. Done.
Yeah. So I stop sharing.
Okay. When is the JEST exam? Date is fixed.
No, sir, I guess
No,
not yet
sir.
fixed.
Okay.
But between July 18th and August 8th, any Sunday it will occur.
Okay. All of you are giving JEST or not?
Yes, sir.
Yes, sir.
Okay. And how many applying abroad? Anybody?
Yes, sir.
Who? Jahan and Avinash. Who is applying?
Yes, sir. Yes.
Trying, sir.
To.